So probability talks about the chances or likelihood of events coming. So when you're talking about probability, you're looking at chances. What is the likelihood that this event will occur? So synonymously, the word probability can be a chance. So what are the chances that a boy is born? What are the chances that it will rain? So there are usually questions that most students bring to finding out how do we apply probability in our daily lives. Probability happens on a very on a daily basis. So we're going to look at the types of probability. Now I must make mention to say your syllabus has been fashioned in a way that you need to know both the theoretical part as well as the computational part. So we need to understand terms like what is an experiment, what is an outcome, what is a sample space, what is an event. So I'll take a few moments as we are waiting for the others to join to understand a few concepts here. So an experiment is simply the process of measuring or the process of observing an activity for the purpose of collecting data. A sample space is simply the possible outcomes that you may have. That is what we call a sample space. And an event is simply a subset of the sample space. So if we're dealing with, for instance, if we're dealing with a sample space of even numbers less than 10. Can somebody tell me even numbers less than 10? Which are the even numbers?
2, 4, 6,
2, 4, 6, 8.
2, 4, 6, 8. Why not 10? Because it says less than 10. Okay. So this is what we call our sample space. Now the event, what is the probability of picking an event such that this event is greater than 4? Probability that the event is greater than 4. So which events here are greater than 4?
6 and 8.
6 and 8.
We have 6 and 8. So the probability of picking these numbers out of the sample space of the even numbers is 2 out of the total events, which are, how many events we have? 1, 2, 3, 4, 4. So here we have a 50% chance that we're going to pick numbers more than 4. Now, probability has its own grammar that you need to understand. There are words like at least, at most, greater than, less than, okay, no more than. So the prerequisite for this course is that you should have passed your English. So there are certain things that are not, they are more about your English, no less than. So if I'm going to give you a sample space of 0 to 10, and I asked you to tell me at least 2, what are we talking about? At least 2.
Numbers greater than 2.
So we're looking for numbers greater than 2. So this means 2 or more. Specifically, which are the observations that are 2 or more? 2, 3, 4, 5, 6, up to what? Up to 10. And if I say at most 2, can somebody help me? What does this mean when we're talking about at most 2? It means 2
Less
or
than 2 or less.
2 or less, inclusive of the 2. So we're starting from 0, 1, and 2 itself. All right. How about greater than 2? What does this mean? So at most 2 means the symbology we're going to use here is this. X is less or equal to 2. That is at most 2. At least 2, it means X is greater or equal to what? Greater or equal to 2. How about if we say greater than 2? What are we looking at? Probability X is greater than 2. So which values are we looking at? 2, 3, 4, 5, up to 10. Are we including the 2? No.
No.
It's saying greater than what? 2. So everything above 2 except the 2 itself. So we're going to start from 3, 4, 5, 6, up to 10. Similar, less than 2 means what? Probability X is less than 2. So which numbers are there? 0, 1, and not 2. So 2 must not be included because in this case it says less than 2. So it's simply 0 and 1. No more than 2 means what? The same as at most 2. So this means 2 and below. No less than 2 means at least what? At least 2. So this simply means X is what? Greater or equal to 2. So we're doing our glossary here, our grammar for those of you who missed grade 1. Are we together so far? I don't want to lose anyone. Are we together?
Yes, we are.
Yes, we are.
Okay.
Of the one where you've written the oh, okay, so it says P X is it greater than 2? No, less than 2. Oh, okay. It's okay.
Right. So now I'm also going to take you through what we call permutations. All these are basics of what? Probability. A permutation is simply an arrangement, different ways of writing patterns. So if we're dealing with permutations, we're dealing with different patterns of arrangements. So permutations are simply arrangements which consider what? The order. So in how many ways can 3 people pose for a photo? So we're looking at what? A permutation of 3. So there's a symbol on the calculator, which I now need you to acclimatize yourselves with. It is called a factorial. So I'll start with the manual computation. What is 3 factorial? It means multiplying 3 backwards. 3 times 2 times 1, which is what? 6. 4 factorial, it is 4 times 3 times 2 times 1, which is 24. Okay, so this is how we do our arrangements. So I hope you have a calculator with you. Those who have a Casio calculator, let me start with you. Always join my classes with three important things. Number 1, always have your calculator nearby. Number 2, always have your statistical table nearby. And number 3, always have your Bible nearby. Okay, so we want to look at the computations of this factorial. So factorial will be important as we do our probabilities for both Poisson and our binomial distribution. So let me take you to this calculator, which is called our Casio calculator. This is the easiest calculator you'd ever come across. So to find 5 factorial, you simply go 5, then shift, then the button just below shift, it has an exclamation mark. For the Casio, it looks like that. For the Sharp, it looks n factorial. I think it is on number 5. So can you press with me 5, shift, and the number below there? Manually, this means 5 times 4 times 3 times 2 times 1. So 20 times 6 is what? 120. When you press it on a calculator, what are you getting? 5 factorial, what are you getting?
120.
120. Are we all together? So a factorial is a number multiplied backwards. Except for 0, it's a unique factorial, it will give you 1. So if you press 0, shift, and that, then equals, it will give you 1. Now, factorials are very important in mathematics because they help us come up with different arrangements. Each one of you has a different NRSC number because they use what we call permutations. How many ways can we, from a committee of what? Or from 5 people, how many ways can we pair them up? In how many ways? So this is now a permutation. It is called 5 permutation 2. The general formula for permutation is given as follows: n factorial over n minus r factorial. So if we're going to do 5 permutation 2, we're going to use this formula n factorial. So meaning we're going to have 5 factorial here. Then the difference down 5 minus 2. Then you factorial it. So this is going to give us 5 factorial over 3 factorial. So if we're going to break this one down, what is 5 factorial? It is 5 times 4 times 3 times 2 times 1. And what is 3 factorial? 3 times 2 times 1. So you're going to cancel this and cancel that. So 5 factorial is simply going to be 20. But how does this question come? 5 girls went for an outing. They were posing for photos. This photo can only accommodate 2 people. In how many ways could the cameraman get the photos of 5? It is 20 different ways. Now, if you don't remember this formula, your calculator can also compute that. So you just go on your Casio calculator, 5, shift, then there's a P there. So 5 permutation 2. So 5, shift this pattern, then 2 is equal to, what answer are you getting? 5 permutation 2, what is it giving you?
20.
20, correct. How about 7 permutation 3? What is it giving you?
210.
210. So the calculator will help you do a number of things. So like I mentioned in the previous class, when we started from our topic 1, the mean, mode, everything the calculator can do. Regression and probability the calculator can do. My people only perished because of lack of knowledge. So we're still on the introduction of probability. So that as I get to explain the distributions, I need you to really remember what I'm teaching you now. So before I go any further, can somebody remind me, how do we calculate 7 permutation 3 using this formula here. What are we going to put here? 7 factorial over what? 7 minus
7 minus
3 factorial, correct? Are we all together? Then here, what are we going to have? 7 factorial over what?
4 factorial.
4 factorial. Then how do we disintegrate the 7 factorial?
7 times 6
Multiply
times
backwards.
5 times 4 times 3 times 2 times 1.
Correct. Then how do we disintegrate the 4 factorial?
4 times 3 times 2 times 1.
And this cancels and this cancels. What is 7 times 6 times 5? Is it 210?
Yes, it is.
Yes.
What here? So it's the same. So I want you to understand the manual and the calculator way of computing things. Okay, still on our pre-math, there's also what we call a combination. A combination is a different way of computing patterns, except that this one is particular of content, not of the order. So it is given by 5, it's given by n combination r. The formula is n factorial over n minus r. It's a similar formula, except that our radical, which is r, becomes the multiplicand again here. So if you're dealing with 5 combination 3, so using this formula, you're going to say 5 factorial over the difference, which is 5 minus 3, times the radical itself. We call this a radical, the one which is at the base, 3 factorial. So if we're going to expand this, it will be 5 factorial over 2 factorial times 3 factorial. So how do we expand this? 5 times 4 times 3 times 2 times 1. Then how do you do the 3? 3 times 2 times 1. Then how do you do the 2? 2 times 1. This cancels. The 2 times 1 goes there 2. So if you're going to find our 5 combination 3, we're going to get a 10. So 5 combination 3 can also be written in a column like that. It's the same thing, 5 combination 3. So with what has been said, I want somebody to help me. 6 combination 4, how do we do this? I want you to follow the same pattern. 6 combination 4, what do we write? Yes, 6 factorial over what? The difference
6 minus 4
Over
factorial
4.
what?
yeah,
4.
Times 4
4
factorial.
factorial.
So this is 6 factorial over what? 2 factorial, 4 factorial, which is going to be what? 6 times 5 times 4 times 3 times 2 times 1. Then the 4 factorial is just going to be, it's simplified there. And the 2 factorial is just going to be that. So what is 2 into 6 is 3. 3 times 5, we get a 15. So what am I talking about? What are these computations you are doing and how do we apply these computations, you understand them later on. This is the toughest topic. So if you understand these basics, then whatever topic you're going to learn in this course is easier. So again, the calculator can also help you compute these figures here by going to your Casio calculator. 5, don't do shift this time, just go direct. 5 combination 2 equals, what are you going to get? 5 combination 2, 3. What is 5
15.
combination 3? Should give you 10. For the sharp, your combination is somewhere here. Okay, how many have sharp calculators? Okay, so I'll be in Lusaka for a week starting tomorrow. So those I'll be meeting physically, I would want you to learn how to use the tables and the calculators. I will communicate with you. I will move. But for now, I want to try as much as possible to explain the calculator way. So 5 combination 3, you just press 5, then combination, then 3, then equals. It should give you 10. Is that what you're getting?
Yes.
Yeah.
All right. So that is what we got. Let's see. 6 combination 4. Are you getting the same on the calculator? Calculate.
15.
15. All right. So I'm done with your mind-boggling questions. So now let's go to now probability. I'll start with, I call them probability 1, probability 2, and probability 3 up to 4. So I'll start with the easiest probability that you need to know. It is called the random variable. The random variable. From our topic 1, random discrete variable means these are countable numbers. So this distribution always comes in your exams and always comes in your test. So discrete, what is a discrete number and what is a continuous number? So in our topic 1, we learned that discrete numbers and continuous numbers are part of quantitative data. We talked about 2 types of data, qualitative and quantitative data. If we're dealing with qualitative, we're looking at quality measurements, looking at types and categories, looking at information that you cannot what? Measure. That is called qualitative. Quantitative, these are figurative, measurable observations. There fall under 2 categories. There's continuous and discrete. Continuous are fractions or decimals, like the weight of somebody. That is continuous quantitative. But if we're dealing with discrete, like how many children are born in a house, how many times you attended class, these are discrete numbers. They're countable, whole numbers in short. So when you're dealing with discrete, you're dealing with whole numbers. So whenever you see numbers like this, you have maybe 1, 2, 3, 4, and 5. Then you're given the probabilities. Maybe this is 0 0.2, 0 0.1, 0 0.3, 0 0.2, and 0 the total must always be 1. So discrete random variable, they would always want you to find 2 things, the mean and the standard deviation. So how do we find the mean? So the mean, don't use the mean from topic 1, statistics. Don't use that mean. We just multiply our mean is simply the value of x times the probability. Make sure that here the total is what? Is 1. So let's multiply this one times that one, it's 0 0.2. 2 times 0 0.1, 0 0.2. 3 times 0 0.3, 0 0.9. 4 times 0 0.2, 0 0.8. And 5 times 0 0.2 is 1.0. So when you total up, you get the mean. So this is 10, 11. So 21, carry 2. So 3.1 here, which we have as a summation of what? XPX. Probability of X here. So when you apply these two, you get our what? Our mean. The mean is generated by mu. So I want to make it harder for you to fail than to pass. So you multiply this by that, this by that, this by that, this by that. The total is called your mean or expected value. Sometimes they use the word expected value. Find the expected value. That's how you find expected value. Any questions at that point? Then you can square these values of x. We have 1 times 1 is 1. 2 squared, 4. 9, 16, and 25. Then you can bring back the probabilities here as they are. Don't square the probabilities. 0.2, 0.1, 0.3, 0.2, 0.2. Now, when you multiply the random variables of x squared times the probability, this helps us find our variance. So let's multiply it together. This by that, 0.2, 0.4, 2.7. This one times that one, we get what? 3.2. This one times that one, we get 5.0. Then we top up, we add them up here. So this is 6 plus 7, that is 13, plus 2, 15. So carry 1. So this is 6 plus 5, 11. So this total here, we call it what? The sum of what? This is summation of x squared, probability of x. This is summation of x, probability of x. This one directly, we call it the mean. If you're going to not use my table, you can simply expand it to say 1 times 0.2 plus 2 times 0.1 plus 3 times 0.3 plus 4 times 0.2 plus 5 times 0.2. When you compute that, you're going to get 3.1. It's the same thing. This is called our mean. The other term is called the expected value. Now, mwafika hapa, you are being asked to calculate the variance. The variance is simply summation of x squared to the power x minus the mean squared. So here it is 11.5. Our mean was what? 3.1 squared. So can somebody calculate that? 3.1 times 3.1. I don't have my calculator. Should give us 9.61. 9.61. When you subtract it from 11.5, what do we get? 1.89. So this is what we call our variance. The problem I have with most of you, I don't know, formula mean summation of x over n. Variance summation of x squared minus summation of x to the power 2 over n. Now, don't abuse these formulas. This is the only point where you are going to not use these formulas here. These are in statistics topic 1. N. So the mistake that your friends will make, they will add on this one here and they call it summation of x. Wherever they get their n, I don't know. Here is the easiest probability you could ever get. Don't use that formula. My formula is near hapa. The only formula that is consistent is the standard deviation. Always, when you square root the variance, we call it standard deviation. So SD here will be the square root of the variance. So can somebody help me? What is the square root of the variance there?
I'm getting 1.374.
1.374. Do we agree?
Yes.
Okay,
Yes.
so we're all agreeing. So 1.374. Now I'll ask a question since I already taught this. Can somebody tell me probability of x is greater than 3? From here, what is the probability of x is greater than 3?
So, apply 4 by
What are they asking us to find?
probabilities that are above 3, that are greater than 3.
I think your mic is quite faint, unless I'm.
Okay, maybe I'm saying they're asking about the probabilities that are greater than 3. So in this case, we have 4 and 5.
Correct. So we have 4 and 5. So did you hear him clearly?
Yes.
So he says they're asking us to find the probabilities of that are greater than what has been asked for there. So that's how he picked from the explanation that I'd given earlier on. So in this case, we're told the probabilities of greater than 3. So which numbers are greater than 3? We don't include the 3, it is 4 and 5. Okay, so what are the probabilities of 4 and 5 in this case?
Zero 0.2 and 0.2.
Excellent. The probability greater than 3 will be the probability of x is 4 and the probability of x is 5. So you identify the actual probabilities. For 0.4, it's 0.2. Of probability of 5, it is also 0.2. And when you add these two, you get 0.4. That is how you find the probabilities respectively. Okay. So suppose you're being asked to find the probability at most 2. Can somebody tell me at most 2, what are they looking for? If they said find the probability at most 2, what are they looking for?
A probability that's 2 or less.
2 or less, correct. So we're looking at the vocabulary, the glossary, 2 or less. And which ones are 2 or less?
2 and 1.
Excellent. 0.2 and 0.1. Then when you add them, you get 0.3. Now, sometimes or always I like to actualize what I'm bringing so that you see that it comes from the exam. This was the previous exam your colleagues wrote, 2022. And now I'll take you to a discrete random variable question, and I want you to attempt it with me. So when you go here, I want you to feel that you're learning. This is question number what? Number 3. Remember what I was saying? You need to also understand what? The terminologies. What is a random variable? Mention the types of random variables in statistics. I'll explain this later on, but I want us to understand first the computation. For 6 marks, calculate the mean calculate the variance, calculate the standard deviation. So I want a lady to help us calculate the mean. One gentleman, the variance, and one lady again, the standard deviation. How do we find our mean or expected value? So Brenda, Concepta, and Charlotte, you can help us find the mean. How do you find the mean? The three of you, any? Who wants to help them? How do you find the mean?
Isn't the mean we multiply the student times the probability?
Correct.
If
The
I'm not
students represent X, the probability Px. So you multiply them. Continue. So 1 times 0.2, 0.12. 2 times 0.15, it is 0.3. 3 times 0.18, it is 0.36. 4 times 0.15 is 0.60. 5 times 0.26 is 0. What? Okay, I'll give you some time. I want you to feel the exam mood. Try it.
Just a minute for me. I'm not done.
Okay, so who can lead us on how to find the mean? The mean, also known as expected value or the expectation, is simply the summation of X and the probability of X. So we're simply multiplying the figures 1 times 0.12 plus 2 times 0.15 plus 3 until the last number 6 times 0.14. What did you get?
3.64.
3.64. Do we agree? Anyone also got 3.64?
I got 3.7.
I got 3.7 as well.
Even me?
7. 3 point what?
7.
3.7.
3.7. Okay. Yes, it's 3.7. The majority. So there's just a rounding off figure. Then the next part, to find the variance, we are supposed to find summation of X squared Px minus a mean part 2. So we're supposed to square this value of X. So if we square it, this is 1, this is 4, this is 9. When you square this, we get 16, 25, and 36. And you will now multiply this with the probability. 1 times 0.12, 4 times 0.15. You multiply all these. What are you getting?
16.28.
16.28.
Okay, so you get 16.28. So the variance will be summation of X squared Px minus the mean squared. So 16.28 minus what? 3.7 squared. So what did you find as your answer?
2.59.
0.59. We agree with that.
Yes, it is.
Okay. So seems you have followed. Okay. So the discrete random variable is the easiest of them all because it is very straightforward. So what's the relationship between the standard deviation and the variance? So this question came from our QM Bible, like I was saying. First of all, I asked you to understand the theoretical part. I was saying discuss what a random variable is and the types of random variables. So the random variable is an outcome that takes a numerical value as a result of an experiment. The value is not known with certainty before the experiment. Examples of a random variable would be tomorrow's high temperature, or the record would measure the temperatures throughout the day. There are two types of random variables. We have continuous random variable and what? Discrete random variable. These are the two types of random variables you need to know. So we went to this example which came in your exam. To calculate the mean, we just multiply the value of x times the probability, and all of you got the mean of 3.7. And to find our value of the variance, you found, what did you find? The variance was, did you find 2.59? What did you get?
Yes, that's the one.
0.59, and when you square rooted it, did you find 1.61 as a standard deviation? The square root of the variance is 1.61. Okay, so if all of you got that, then I'm glad. So he brings most of these questions from here. My homework for you will be to find the variance and the standard deviation for this question. So you can screen grab this or send it on the group so that you try that. For tomorrow. So I'm remaining with 15 minutes. I will introduce you to another concept quickly, which is called conditional probability. Conditional probability has what we call axioms. Axioms are simply properties. These properties are about 13. Number one is that probability must always range between what? 0 and 1. Meaning you can never get a negative or anything more than 100%. The next axiom simply says when you are uniting A and B, you're adding. To unite is to add. So probability of A union B is simply the probability of A plus the probability of B minus the intersection. So intersection is the common ground. So if you are sharing QM and taking other courses, if you're taking 3 courses, so what A has plus what B has minus the intersection is the total number of courses you're taking. So this is the union set. To unite is to add. The word unite comes in the form of or. So you can make subject of formula A intersection B, therefore becomes what? Probability of A plus probability of B minus the union set of A and B. So this is how we progress this. Then we go to the complement. Complement is what I do not have. Probability of A plus the complement will give me 1. What this means is if A is 20%, the complement of A is 80%. If B is 0.4, the complement of B is 0.6. So complement is simply what is outside. So if this is A, what is complement of A is everything outside A. This is what we call the complement of A. Are we following? Number 5, we get to what we call the basic rule A intersection B for this joint sets would be A intersection B. To intersect is to multiply. So you can only use this as a last resort formula. Otherwise, we call the intersection formula as a prostitute formula because it has 5 formulas. It takes a number of forms. So using conditional probability is a pattern. A given B, the B comes down there. Then you intersect the two letters A intersection B. So if I were to ask, if A intersection B is A given B, if A given B is A intersection B over B, what is B given A? The bottom guy will go
A
down.
comes down.
And on top, we're going to intersect A and B. We can either write A intersection B or B intersection A. I love bringing the alphabetical letters which come first, but it's all good. Just as this 2 times 3 is 3 times 2. But A divided by B is not the same as B divided by, we don't call this divided by, it's conditional. I'm trying to say 2 divided by 3 is not the same as 3 divided by 2. Be careful. Umga is square punch. That is the first thing you need to remember. So when you cross multiply here, it is A given B. When you multiply it by probability of B, you're going to get what? The intersection of A and B. Uunga yoku arapera intersection. Same no B given A. When you multiply it by A, it will give us what? The intersection. A per mode. So just take note that if the bottom is a multiplicand, you'll have an intersection. So whenever this condition of probability is the multiplicand, you're going to get an intersection. So even if you close your eyes, X given Y, what do I multiply this one to get an intersection? I multiply it by the base of Y. So this will be X intersection what? Y. Or if I had Y given X, what do I multiply this one by to get the intersection? Times the probability of what? X. All right, so an examiner will just bring a question to say, suppose the probability of A is 0.3, probability of B is 0.4, probability of A given B is 0.5. Part 1, find the intersection of A and B. But I wish the intersection apapata. Just expand this guy here. Just say, since I know that A given B is equal to what? A intersection B over the bottom guy, which is what? B. That is the starting point. The second point is now you substitute what you have. Upper A given B, not quarter 0.5. A intersection B, we don't know. But the probability of B, we're given as 0.4. So here we're going to put 0.4. You cross multiply. So 0.4, 1 times A intersection B is simply A intersection B. 0.5, you multiply it by what? 0.4. What do we get? 0.2. Sharp one. But if you forget, the shortcut is always ngawashibata. Just ask yourself, A given B, who is the base? The base is B. If you think parana, automatically you're going to get the intersection of the two letters. All right? It's not a shortcut per se, it's an admissible formula. So A given B is 0.5. Probability of B is 0.4. If CBD, when you multiply them, you get the intersection, which is 0.2. So you're getting the same answer here and here. So these things are theories of dead men. Now, so you just need to understand or memorize with terrible exactness. So what I'm trying to bring across is conditional probability only exists when there's this slash. If you think that Pachiba would have just multiplied probability of A times probability of B to get the intersection, which is 0.12 sharp. But this one overpowers that basic reference, and that is the last resort formula. You only use it when there's no conditional probability. Mali, what is the probability of A union B? Anyone?
So it's
Huh?
it's the probability of A plus the probability of B minus the intersection.
Excellent. Minus intersection. So what this means is apanga wakasa pamurunisha pena wala kasa, because this is dependent on the formula you got there. So 0.3 plus 0.4 minus 0.2, which we just calculated here. We're going to get 0.5. So this is called our union set formula. Who can give me what is the probability of the complement of A? And what's the probability of the complement of B? If A is 0.3, what is its complement? It is 1 minus itself. Complement
0.7.
So 1 minus 0.3 is 0.7. Inga, what is the complement of B? If B is 0.4, what is the complement of B?
0.6.
0.6, correct. Hapana papata, you cannot get a 0 in this exam unless you just want to. All right? Unless you just want to. So, before I go into the depth of this, now I'm table at the it is called a contingency table. But if the few that I've talked about, you bring it a table like this. You say A, maybe B here, X, maybe Y here. Then you put the figures mkatum 2, 4, 6, and 8. The first thing you do is you total up the tables. Rasangama totals. Upper B total, what's the total for B? 8. Upper Y, what is the total? 12. A, what is the total for A? 6. X, what is the total for X? 14. Then to write the total per total. This total is the same as that total. When you total up here, we're going to get what? A 20. Then they'll ask you number. What is the probability of A? What is the probability of A? So to find the probability of A, you find the total for A, which is 6. I am our totals. In total. So total for A is 6. So to find the total for A is to find the number of A elements over the total number of events. The total for A is 6. The grand total of events is 20. So 6 over 20 is 0.3. How about the probability of B, Mali? How do you find the probability of B?
So it's 8 over 20.
Para pali B. Total ya B ni shinga ni 8. Out of the total events, 20. So it will give us 0.4. Any lady to give us probability of X? And any gent besides Mali to give us probability of Y? What is the probability of X?
X is
14 over 20.
14 over 20, good, which is 0.7. A gentleman, probability of Y? Anyone?
12 over 20.
Get 12 over 20. All right, which is 0.6. Tulipamo, anyone behind at this point?
Yes,
Can I repeat what I said? Or you have a specific question?
the probability of B.
Bali B twala punch total ya B ni shinga ni 8. A8 over the total events here 20. So 8 over 20, 0.4. Same A total ya A 6. 6 out of 20, 0.3. X 14. 14 out of 20, 0.7. Y 12. 12 over 20 is 0.6. Are we together?
Yes, thank you.
You're welcome. Songa twaya kuli A intersection B. Kuchecking pabale kumana. A and B, they are meeting at 2. So you see 2 over 20, which is 0. What? 0.1. So who can help me? X intersection Y? X
8 over 20.
Mhm.
8 over 20.
8 over 20. All right, do we agree with her? 8 over
Yes.
20. So vale kumani na pisa. We go on 8 over 20. So 8 over 20, which is 0. What? 0.4. Okay. How about A given B? Who remembers how to expand A given B? A intersection B, but down we're going to put what?
B.
A B. So what is our A intersection B? 0.1. Yeah, fine. What is our probability of B? 0.4. So this will give us 0.25. Or mwanawe pa bali kumani na A na B, bali kumani na pesa? Bali 2. But the total, not the probability, the total for B. What is the total for B? 8. So this is the same as 1 over 4, which is 0.25. Whichever you're comfortable, you're going to get the same answer. I repeat, you can use the same formula, B arrives upon C, then A intersection B. So your A intersection B is 0.1. The probability of B is 0.4 because we calculated it here. When you divide this, you get 0.25. And this is straightforward, isn't it? The shortcut is just draw a plus. A na B bali kumanya pesa, pali 2. But you get the total for letter B. Letter B, what is your total? 8. So you put 8 there, which is 0.25. Using any of the two guidance that I've given you, help me find the probability of X given Y and the probability of Y given X. The ladies, a lady and a gent. What is X given Y?
Probability of X given Y is going to be probability of X intersection Y over probability of Y. So our X intersection Y was 0.4. The probability of Y was 0.6, if I'm not mistaken. So 0.4 divided by 0.6 will be 0.66.
Okay. 0.66 or 0.67. The shortcut?
The shortcut is probably common in X and Y is 8 divided by the total for Y, which is 12. 8 divided by 12 is 0.67.
Same answer, correct? Wow. What's your name?
Mwanza.
Wow. That is very good. All right. Y over X, the gents. Y over X.
0.57.
How did you get that?
So where Y and X intersects, that's 8. Then the total for X, that's 14.
All right. Now, lastly, how do you find A union B? And how do you find X union Y? The gents and the ladies, give me the formula.
So A union B is equal to probability of A plus probability of B minus the intersection A intersection B.
So what was our probability of A? 0.3 and 0.4 for B. The intersection was 0.1. Okay, 3, 4, 1. So we put them there. 3, 4, 1. The final answer will be 0.6. The ladies, what is A union B? Probability of X plus probability of Y minus intersection of X and Y. So where there is probability of X, we already found 0.7 and 0.6. The intersection 0.4. So 764. Okay. 764. And when you compute that, you get 0.9. So your homework will come from one of the test questions. This also came in an exam. We are told that we have a data set of the number of cars in a local dealership. Sedan, SUV, they are new or they are used. So you're being asked, find the probability that the car is new. Who wants to try just from looking here? You get the totals first. All right. Probability of new is the total for new over the grand total. What's the probability that it's a sedan? You go to the total for the sedan over the grand total. What's the probability that it is a new sedan? There's a word end pakati hapa. New sedan is new and sedan. So it's A intersection sedan. So you go where they meet, A intersection sedan, then the grand total. What's the probability that it is either used or? I told you the word or means what? Union. So I need you to do this as your homework. This is how exam questions come. 11 marks. Are we together? 11 marks. Unless there are
Yes,
any
sir.
questions.